Okay, welcome. This is linear algebra, math 346. Well, elements of linear algebra. My name is Jhevon Smith. I'm the instructor. You can call me Jhevon, that's fine. My email is listed here. Very important. I'm going to be asking you to email me in a few. Office hours by appointment. That's my website. Also a very important thing you need to know because I'll be sending you to the website pretty soon. Our standard text for this class is Elementary Linear Algebra by Howard M. It's the 11th edition, and that's the latest one. There you see the math department location and the website, and the 346 website, which is also important because I'll be sending you there as well. So there's a little blurb about why I gave you the websites. My website in particular is where you're going to be seeing things like reviews, announcements, solutions to tests and quizzes that I'm giving, and all that good stuff. I also have some supplements that I think would be good for this class. This class will involve proofs. You'll need to know how to read proofs and understand them. You'll need to know how to write proofs. So not everyone would have encountered that, I don't think. Has anyone taken a proof class before?
Is that like a class in which people did proofs, or a specific, like an entire class dedicated to proofs?
Well, did you have done proofs at all?
Yes.
In high school.
Yeah. In high school?
Yeah.
Okay. It's something, I guess. That's something. All right, so if you're not too strong on proofs, I gave you a link here that'll help you through that. It's actually a website that talks specifically about proofs that you will do in this class. It was actually developed by the publishers of the text. So that would be a good resource to check out, and you have the link there. Name's Keisha.
Yeah. Yes, it is. Just move this.
I guess. That's okay. What's your name? Last name?
TSY.
All right, 2 is another linear algebra text, which is it's a nice text. A lot of people like this text. Ron Larson's Linear Algebra, 6th edition is the current one. I'm pretty sure you can, like, I'm not condoning or recommending that you do this, but I'm pretty sure you can find it online, like a PDF or something. 3 is a very nice thing I discovered recently when I found out that I was going to be teaching this class. It's a linear algebra course that you can take online. What I really like about this is it's really geared towards, I realize 346 is like linear algebra, it's not only for math majors, but it's also for computer science. And it seems like I have quite a few computer science students in the class. So this course here, number 3, under the supplements, Coursera's linear algebra course, it's called Coding the Matrix. It's actually a linear algebra course designed specifically for computer science majors. Right? So a lot of you might be wondering, why do I even need linear algebra? Right? So what you can do is you can go through this course, and it actually, you complete the assignments using programming. I think they use Python programming language. So it's a pretty good resource where you can actually go and learn linear algebra specifically to apply it in a computer science context. And I think that's really cool. I think the course actually starts tomorrow. So I'm pretty sure it's free. So if you want to really apply it in a computer science context, if you're a computer science major and you want to practice your programming while learning linear algebra, I think it's a really cool thing to look into. I've never actually done it myself, but I was looking through the syllabus and all that, and it seems pretty nice. Another book is number 4. You see Sheldon Axler, Linear Algebra Done Right. It's a more advanced text than we'll be using. It starts a lot more general, and it's a very different format from what we'll be doing, but it's a good resource. Number 5 is Linear Algebra Done Wrong. I assume it was written in response to that one, and that one is actually freely available at the website that I linked you to there. Another interesting article is number 6, just something to read for edification, so where you can see how linear algebra is actually applied in real life. So you can sort of read, because sometimes we're going to be doing things in this class and you're like, how does this help anyone? Right? Like, I think it's good for you to actually see the application. So I think resource 3 and resource 6 is actually a good thing to check out. You'll be able to use technology on your homework and quizzes, but in class I won't allow calculators or computers, so be aware of that. The grading scheme is listed here. Of course, it goes with the GPA and all that. So according to the math department policy, your final exam is worth 40%, but I can control the other 60%, and it's broken down as you see here. So we'll be having quizzes, which will be 15% of your grade, and I'll be giving quizzes often, like expect at least one a week. You have written homework and online homework, 5% each. I'll drop the worst 2 homeworks. Participation, so I'll be taking attendance pretty much every class, and you'll actually get points for showing up. So yeah, so everyone in here should get at least 5%, right? I mean, the eraser will get 5% just for being here, so doesn't know any math. You guys should get it. So yeah, we have in-class tests. I plan on giving 4, I'll drop 1, and then there's the final exam that will be cumulative. The date for the final exam, we already know, it's on May 25th. It's from 1 to 3:15, and it will be in this classroom, FYI. But we'll get to that. Okay, so far so good.
Wait, what time is the final?
1 to 3:15. I think it's on a Wednesday, May 24th. Okay. Moving on. Extra credit. I normally don't give extra credit, but I was really sort of impressed with how resource 3 was sort of set up. So I figured if anyone actually goes through that course and actually fully participates in that course, I could be convinced to give you very generous extra credit for doing that. Actually going through, doing the assignments, writing the programs and getting the assignments done and going through the course. If you do that, they'll actually give you a certificate at the end, I think. So, anyway. There will be no makeup exams or quizzes, so don't miss any. There's the attendance policy. Basically, always be here, always be absent. Never be absent. Okay, what else? Moving down to my expectations. Work ethic, basically don't slack off. I'm going to be working hard from day 1. If you slack off in this class, it's not easy to catch up in a class like this. Responsibilities. Okay. Basically, I'm saying here that I expect more from you guys than from the average math student, the average calculus student, because you've passed that, you've gone through Calc 3, and you've been deemed good enough to take approved scores. It's actually going to be, so I expect you to be responsible and do all your work and blah, blah, blah. Homework. Here in this section, I told you how to access the online homeworks. I also talk about due dates for the homeworks, for the written homeworks as well. So that's just some information there that you can read. When you hand in written homework, specifically, I want you to label things a certain way. As you're going to realize in this class, organization is very important. So in everything we do, we have to be organized. So when you're handing in written homework, the heading, I want you to set it up. I want you to write your name first. Your name, Smith. Then you write the homework number that you're doing. So at one of the last pages, there's a list of all the homeworks that you'll be doing for the class, all the written homeworks. So what I want you to do is I want you to write the homework number, right? Your name, the homework number, right? Which is in the most far left corner here. Right? And then the topic. So for example, if we're doing homework 1, when you write up homework 1 and you submit it, you say, this is homework 1. matrices, and matrix operations. So when you're giving me homework, write your name, write the homework number that you're doing, write out the topic that you're doing. This should be at the top of your page. I don't care if it's on the left or the right, but this information should be on every piece of homework that you hand in. Show all your work. It's very important that you explain yourself in this class. So don't just write the answers down and expect to get any credit for that. Like in tests or anything like that, I expect you to fully explain yourself. And we'll talk more about that soon, I guess. The only thing where we might, we'll get to that. If your homework has more than one page, please staple it. Don't just crease the papers and hand them in, because they get separated and it causes all sorts of mess. Make sure it's properly labeled. Only one homework per stapled group. So for example, let's say in one class I complete 2 topics. Generally how the homework goes is once I complete a topic in class, the homework for that topic is due the next class, right? So if in today's class I finish section 1. The first topic we're going to be doing is 1.3. If I finish 1.3, homework for 1.3 is due on Wednesday, right? The next class is when the homework is due. Now let's say in a class I complete 2 topics, right? I do 1.3 and 1.1. I expect you to staple the homework 1 separately from homework 3, right? Homework 1 and 2, they should be separate, right? Every packet must have only one homework. Okay? That's also a requirement. And be neat. By the way, if you don't follow these instructions, I'm going to take off points. So just so you know. It's very easy to follow these instructions. Don't lose points for stupid reasons. Okay? Here's how you're going to access the online homework. That's the website. And I tell you where to click. Your username is your CCNY email address username, just the first part of it. And something's weird here, it's actually in all caps. Right? The password is going to be the same as your CCNY email password. So if you don't know what those are, you should go into CUNY first and try to figure it out. Try to reset your password or whatever, because you're going to be using it. Okay? And once you log in, you'll see the list of assignments there, and there will be due dates and all that. So it's good. More expectations. I expect you to remember all the math you've ever done in your life. Basically, don't forget anything. There are a lot of times we're going to be looking back at things that you've already done, and I'm going to be drawing examples from previous math classes, and you'll need some knowledge of what you've done before. For the most part, things are going to feel kind of new, what we're doing, but what you'll realize is a lot of previous knowledge will help in this class. So that's something you should make sure. If you're weak in anything, if you're weak in your calculus, your algebra, your pre-calc, if you're weak in arithmetic, we'll talk about that more. Make sure you have that down. Okay, next section. Contact, very important. Email me today, right, with the information. Tell me your name, tell me what class you're in, tell me the section. So you're going to email me at the email that is listed on the front page of the syllabus, not at my college email, right? So you're supposed to email me your name, so basically say Jhevon, and say something like, I'm in your 346 class. I teach several classes a semester, so I want to put each class in an email list. So it's very important that when you email me, tell me what class you're in, and I'll be able to organize you in the right listserv. Okay? And it's important, I'll be sending very important emails every now and then, as well as I have an online grading system. So what's going to happen is once I start putting grades in, I can send you a report, which will be sent to you by email. And so you'll have always your current grade. You'll be able to check it at any given time, right? You'll see what grades I have for you. So it's very important that I have your email so you can be up to date on how you're actually doing in the class, and you can see your current progress at any given time. So it's very important that I have your email, as well as if there are any important announcements or anything like that, I'll be sending it to your emails. Use an email address that you check often, right? It doesn't have to be your college one, whatever one that you check often, that's the email I want you to email me from. I'm not going to spam you. I'll only email you when it's important. Feedback. I encourage feedback. Right. So I need to make sure you're learning. So I need you to talk to me if anything's up. And if you understand what's going on, or if you think the class can be improved in any way or anything like that. So I'm not opposed to feedback. Just make sure it's constructive, okay? So don't just give me feedback like, your teaching sucks! You know, say, your teaching sucks because you do this, you do that, I think it'll be better if you did this. You know, maybe look at that. I won't downgrade you or anything for giving me negative feedback. And if you doubt that, there's an anonymous feedback page on my website. So when you go to my website, there should be, I don't remember where it is, maybe at the bottom left or something, where it says give feedback anonymously. Help. Free tutoring is available in the Marshak building. It's the Marshak Math and Physics Tutoring Center. I also am a tutor there, so you'll be able to see me there a lot of the time. These are the hours for the current semester, and tutoring begins on February 8th, which is next week, Monday. What's your name?
Candy.
Okay. So that's tutoring where you can go and you can sit with a tutor and discuss anything that might be troubling you. I gave you also a lot of other online resources here, mathhelpforum.com, mathhelpboards.com, mathstackexchange.com. A lot of brilliant people are there who will help you out on math forums online. Watch the other YouTube videos. Watch Khan Academy. They all have linear algebra, a lot of linear algebra stuff. There's a lot of information out there. By the way, I will be uploading these videos to YouTube, and you'll be able to watch the lectures. That's why I record it. So it's for your benefit. So if you miss a class or anything, you'll be able to see what we did. So yeah, this class will be on YouTube, right? But there are other sources out there. Have I listed it here? I thought I listed it. I usually do. Where did it go? There's supposed to be another website here, Wolfram Alpha. I don't know if you guys know what that site is. Brilliant site you can use it to check your work. So in this class we'll be doing things like you can find out answers to all sorts of questions from Wolfram Alpha, and you sort of type it in ways that you don't need a specific programming language per se. You can sort of type as you would just asking a person questions, and it can actually figure out a lot of things. So for example, we will be using things like matrices in this class, so you might see an object like this. We'll talk about it later on in a bit, right? Where A, B, and C are numbers, for example. If you're entering this into a computer like Wolfram Alpha, you enter it in the following way. Squiggly bracket. You put the rows as a list in squiggly brackets, and then a comma. Put this guy in squiggly brackets. Right? So typing this on the computer is the same as typing that. The Wolfram Alpha will process this as that. Right? So for example, you might be doing something like finding the reduced row echelon form of a matrix, which we'll talk about that later, don't worry about it. Right? You can literally go to Wolfram Alpha and check your answer. You can say reduced, you can type reduced row echelon form of. And it will actually tell you what the answer is, right? So you can go through it yourself and you can actually check it. So if you want extra practice and you want to practice the even problems in your textbook, you can actually use this website to check your answers. Right? So I don't think there are even answers in the textbook, so it's a good thing to use. I use it all the time myself when I can't be bothered doing calculations. Okay. So yeah, there's a lot of help basically. So I gave you there's a whole paragraph of all these places where you can get help. You can also get help from your classmates, right? You're all in this together, you're all in the same class, you're doing the same things. get together and do homework. I don't care if you collaborate on homework, right? Make sure you do what it takes to understand what you're doing, right? So you should get the contact information of at least one person in the class that you can study with or get notes from if you're absent, sort of thing. Of course, there's always me. You can come and talk to me whenever you have trouble. Usual class rules, no eating, don't cheat. And you can read that whole blurb I have there about cheating. Also attached to your syllabus is the academic calendar. There are a lot of important dates during the semester that you might want to pay attention to. So I decided to put that in the syllabus. You'll notice, for example, that, not a hint or anything, but the withdrawal period begins on February 19th. Right? So if you want to withdraw from the course, if you actually do it before February 19th, it won't even show up on your transcript. It'll be like you would never hear it. Right? After February 19th, you can withdraw from the course all the way up to April 11th, which is the last day to withdraw from the class. So after February 19th up to April 11th, if you withdraw, it will show up on your transcript. You'll see that W, it will show that you withdrew. After that date, you can't withdraw though, unless there's some insane emergency. Right? It tells you we're in spring recesses and all these holidays and all that good stuff. Okay, so it's good to know what's going on. So there's the 346. What's your name? Michael. Okay, list of homeworks from the textbook that we will be doing. If you don't have the textbook and you don't want to buy it, I'm trying to get a copy for the tutoring center. So you can come by at the tutoring center and actually use the book there. I'm not sure if they have it in the library. They might have it, you can check. But it's one of the newer editions, I'm not sure if they have it.
What if you have an earlier edition?
It'll be good for reading purposes, but I don't think the problems will be the same. I think they changed the problem sets. So that's one of the problems. Yeah. So the information shouldn't change too much from older editions. I do know that the older edition is organized very differently from the latest edition though, but I'm pretty sure the numbers of the problems are different. So you'll be practicing different things. Okay. Any questions so far? Or anything? Concerns, comments? Okay. On the last page, you'll see a questionnaire. Please fill this out. It's anonymous. You don't have to put your name on it. Fill it out so I can get a better feel of the kind of students are in this class. Once you're done with it, just tear it off when you're going to hand it into me at the end of the class.
Last semester, were they using the 10th edition?
I think they used the 10th last week. Yeah. So that's that. Any questions? So, I guess in the meantime, we can sort of talk about the class in general, the kind of things we're going to be doing, or at least give you some idea of what's going on. Linear algebra. Super important class. Very, very important class. Especially if you're a math major, it's super important. As far as modern mathematics is concerned, linear algebra is more important than calculus. Like, it applies to everything, including calculus. It's sort of like, I don't want to say the Higgs boson, that's too deep. Maybe said there would be that. Like Spectre from the old James Bond, the new James Bond. You remember Spectre? It was like, you know, I've always been there in the background, and you know, you've always passed me so many times that you never even realize I'm there, but I've always been watching. I'm the author of all your pain. Remember that when he's like James Bond? Yeah, linear algebra is just like that. it's been in the background this whole time. You've been doing linear algebra, you didn't even realize it, right? So it's there, it permeates everything. You took differential equations, like everything, how it sets up, right? Calculus 3. Everything you learn about lines, planes, all that, it's linear algebra. In fact, if you look at chapter 3 in this book, it's pretty much chapter 10 in your calculus book, right? Which I'm not going to go over because I expect you to remember all your calculus stuff. But yeah, it's in the background all the time, right? You ever wonder why an n-order differential equation has n linearly independent solutions? Do you even know what linearly independence means? It's all going back to linear algebra, right? It's there in the background all the time. Every time you drew a line, you considered a plane, you were doing linear algebra. So it's a very ubiquitous thing. It's all over the place. So it's a very important topic to learn, and especially if you're going on to advanced mathematics, a knowledge of linear algebra is invaluable. You'll definitely need it. We will be doing very, 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 very basic linear algebra in this course, kind of like a teaser trailer or something like that. But one other thing is that this course is one of the first courses where you're really expected to have very mature mathematical thinking. It's going to be, we're going to be doing a lot of computation, but it's not going to be the focus. So if you have, in your syllabus, if you look at the topics list, yeah, like the first section here, it's computational heavy, but there is some theory, and we will be doing proofs. But all the other sections, it's very, like, you're going to need to know how to write proofs, you're going to need to know how to think mathematically, how to explain things mathematically. It's going to require a lot. So this is really an introduction into what math really is. Most people actually don't know what math is. Every time people think of math, they think of the wrong thing. Now you're sort of finally being introduced. This is like the teaser trailer to the tip of the iceberg of what math actually is, right? So it's really going to be a gateway for a lot of you. That's that. So let's actually, let's see how much you guys remember. Let's start with something sort of familiar and sort of segue into this. Let's talk about sets. Does everyone know what a set is? What's a set?
It's like a formulation of elements.
What do you mean a formulation?
Is it a collection of unique elements?
Yeah. Definition. A set is a collection of objects in the broad sense. Can you tell me about some notations for sets?
Empty set. This will be lines with brackets with the 0, slash, 0, null set.
So it's
Okay.
natural number?
There's something called a null set, right? Its notation is either a circle with a slash through it or empty brackets. This is a set that has no elements. In general, set might look like a list. Right? So there's a list of objects A, B, C, 1, 2, 3. Right? That's how it looks. So you might see a set that looks like that. Or you can define the numbers that give it by a certain property. So for example, I can say a set is something like the set of all x. This bar here means such that. And then I can give you some condition that it must fulfill. Set of all numbers between 1 and 5, where x is an integer. And this would be equal to, right, 1, 2, 3, 5, right? So instead of listing out the integers between 1 and 5, I can give you this condition. Why do I need that condition? Well, yes.
Is there a way to write this set of all numbers that are integers?
Yes, I'm getting to that. So why you'd like something like this as opposed to that is because sometimes lists can get incredibly long. So, for example, if I want to list the first 100 positive integers, I'm not going to sit there and write down 100. There are a couple of ways I can do it. So, for example, I can write I can use ellipses to show that I'm repeating some sort of pattern, which whenever I use ellipses, the pattern should be obvious. And then I can put like the last number here. And it's obvious that this guy would be equal to the set of all x such that x is between 1 and 100. X is an integer. For example, sometimes you name sets usually using uppercase letters. Say A is the set 1, 2, 3. Right. So every time from this point on, once I make this definition, every time you see me write A later on in that proof, you understand that I'm talking about this set, right? There are also very important sets. Have special name symbols. Right. One very important set is the empty set, which we already spoke about, and some other important sets are sets like Z. Right? What is Z? Boldface Z. This is the set of all integers.
Whole number.
Yes.
Positive and negative.
Integers means whole numbers. Positive and negative whole numbers. And 0. Right? So Z, if I write Z, I'm talking about the set 0, plus or minus 1, plus or minus 2, etc. Forever. It's an infinite set. You also have sets like N, and it's called the natural numbers. This is defined as, it has two definitions, usually. It could be all the positive integers, or sometimes the non-negative ones. It might start from 0. It really depends on the source you're reading from. Usually in a textbook, if they're going to use this symbol, they'll tell you at some point, this is what we consider to be N. Sometimes people like putting 0, sometimes they don't. Negative integers. So whenever you see me write that, this is what I mean. So, another important set is the set, take R. What is R? Real numbers. Right? Basically all the numbers on the number line. Okay. Other important sets. C. What is C?
Complex.
Complex numbers. How do you define the complex numbers? Describe it.
Is I included in the complex number?
I is included. Give me a definition.
It doesn't lie on those lines, so it wouldn't lie on the real line, the real number line.
It's an imaginary number.
Yes. Give me a definition.
Oh,
Give me a nice way to write it down. What does a complex number look like?
A plus bi.
A and B integers.
A and B are?
Integers.
No.
No, just
Real numbers?
Real numbers. Right? This symbol means is an element of slash member of. So me saying A, B, this symbol R means A and B are a member of, are members of the real numbers, right? This is a set that defines the complex numbers, right? So example, 1 plus 2i, or 3i, or radical 5 plus 7i. These are all complex numbers. They're an extension of the real number so that we can solve basically all polynomials and get n solutions for an n-degree polynomial. Let's talk about something else. F. Who knows what F is? F means R or C. So whenever you're reading like an advanced math textbook and they put F, basically they're saying you can think of this as applying to the real numbers or the complex numbers. Not everything applies to both of them, right? There are some things that will only work for real numbers, but when you use complex numbers, everything messes up. There are other things that will work for complex numbers, but they won't work for real numbers. Whenever it can work for either or, people usually use the symbol F to denote this, right? So whenever they say F, it means you can think of this as being in the real numbers or in the complex numbers. It will work in both cases, right? So that's another thing. Let's look at something like this. Rn. If I write R to the n, or any of these sets to the n, what do I mean?
Which is like, that would be a 1 by 2.
n represents the number of dimension, first week.
Okay, give me
So it's
a
like,
specific way to write it down.
if I want to say I want to like grab a symbol in the R3 region, this is like an example, like how do I define it like specifically?
There it is.
Vectors.
Vectors, how would you write down a vector?
Like smaller sets of 3 numbers. Except they're not sets. Just blanks. Like 3 dimensions.
Think of it as a set of coordinates, right? So
Yeah,
it's like
that's what I was
x1,
thinking.
comma x2, all the way to xn. Right? So it's this is called an n tuple. Right? Set of all coordinates such that the numbers come from the base set here. So your xi are from R. Right? And a similar definition would apply to something like Cn. Right? So it's just a set of all such that all your zi's are in C. Right? So it's a set of all coordinates. So, example, if I write R2, I'm referring to the 2D plane. Right? R3 refers to 3D space. Right? R4 would be 4th dimensional space. And the way we think of these are the set of all coordinates that have real number entries in them.
I'm not registered yet.
Okay, talk to me afterwards. Okay. So those are sets. They're going to be very important as we're moving on. These are just some of the sets you're supposed to know. I guess as time goes on, I'll be defining some more. But I guess I want to move on now. So for example, knowing about sets and how they operate is something that's going to be important here. Let's move on to something else that's pretty nice. Talk about functions. What's a function?
Something that maps values from one value to another.
Something that maps values from one value to another?
I don't know. I think that's what it is in here.
Where are the inputs and outputs coming from?
Real numbers.
No, any like particular sets.
Sets. Function f from a set A to a set B is a, how do I describe it? Say unique, that might give you the wrong impression.
Particular?
Assigns to each element in A exactly one element in B. You'll see us write something like F colon A arrow B. This is the function from A to B. Right? The name of the function is the letter F. Right? So F is the name of this function. The set A is called what? Name for the set A. It's called the domain. The set B would be called what? No?
The output?
No? Codomain. What else do we do? What's the set of elements in B that are assigned?
Right.
This is called a range. These things are going to be important later. By the way, this is good practice. You see how every time I'm talking about something, I can write down specifically what it is. It's not, well, it's kind of like this. No, you need to know like what things are exactly, right? Rn is the set of all coordinates where the components are all real numbers. It's very important that you're going to have to be very specific in this class. So, an example, of course you've seen many examples. Say I have a set with 0, 1, 2. This is my domain A. Over here, I have the codomain B, which is -1, 3, 1, 4, 0. Right? And I define my function f x equals x squared, what happens? The 0 would be assigned to what number?
0.
0. 1 would be assigned to what number?
1.
1. You're just squaring the element. 2 would be assigned to what number? 4. So if I ask you what is the range of f, what would you say?
0, 1, 4.
0, 1, 4. Right? Notice that not everything in B is in the range, right? B is called the codomain. Only the elements that are actually assigned to something we call the range. And we think of it as a set, right? So it's called a subset of B. So you guys understand what a subset is. I'm not going into terribly too much detail here because technically this is sort of a review. So if B equals R, or a subset of R, then f is called a real valued function. Right? So pretty much everything up to calculus 2, you are only talking about real valued functions. A lot of it, calculus 3 is also talking about real valued functions, but in calculus 3 you also talked about vector functions, where you're mapping into Rn, is one possibility. Usually you're mapping into R3. So things like calc 1, functions are usually from like A to R, or calc 1 and 2. If you go to calc 3, then sometimes you'll have f going from something like R2 to R. Right? These are like the guys that are f of x, y. Right? Z equals f of x, y. Every time you were looking at a function like that, you were thinking of this. Right? Or you might have seen functions from R3 to R. This is if you see something like w equals f of x, y, z. So that's an example. If you have a vector function, other things that you've seen before. So from calc 3, we see something like r of t is equal to 2, 3t, 5t squared. This you can think of as an example. It was a function from R to R3. Right? Notice that there's only one element here, which is usually like a real number, but I map it into a vector, which is a coordinate with 3 elements, which means the set here, the output, is R3. In general, we're going to be keeping it simple in this class. We will care about functions from Fn to Fm, right? So we're usually going between spaces of vectors to other spaces of vectors, functions between vector spaces. In this case, f is called, we don't use the name function anymore, we use the name transformation. So in linear algebra, we're not going to be talking about functions per se, we're going to be talking about transformations, which is sort of a more general thing than what you've been seeing up until now. So an example of a transformation. Let's say t goes from R2 to R3. So I'm going to take a function that goes from the 2-dimensional vector space, real vector space, to the 3-dimensional real vector space. So I can say something like t of xy, right? These are the set of coordinates, is equal to, I can go to some 3-dimensional coordinate. 2x plus 3y, 5x minus 2y, 7x plus 3. So that's an example. I give you a coordinate, and you use those two inputs to give me an output in a 3-dimensional space. Right? So this is an example of a function. This is just the intro class. I'm going really fast. I know I'm throwing out a lot of ideas, but I sort of want to give you a picture of where we're going. We're going to be going over all this and defining it in much greater detail, especially transformations. We have a whole chapter on transformation. But that's just an example. Now here's something to consider. What if I was going to something really large, like R4, 5, 6, 7, right? You can have 7 coordinates. And let's say I'm coming from something else that's also really large, like R5 to R5, R7 to R8. Something big, right? Writing it out like this in a list is really going to be cumbersome, and it won't even fit on the page. You have to go into another line. So a lot of times what we do is we try to write things in a different way. So we might think of row vectors, sometimes write it as column vectors. Right? So I'll put the first guy up here. The second guy I put on the second line. Third guy I put on the last line. For convenience. But even that might not be convenient enough for me. I don't want to be writing all these x's and y's. Clearly you can see here that everyone in like the first column has what? An x attached to it, right? So clearly here I have an x column, right? And clearly here I have a y column. So as far as I'm concerned, if it's understood that the first column is the x column, the second column is the y column, writing x and y is sort of superfluous, right? How about we get rid of them? Forget x. Just write 2. And I'd understand that it's multiplying an x, right? Forget the y, just write a 3 plus 3. And it's understood that it's multiplying a y. Forget the x here, that's just a 5. Forget the y there, that's a minus 2. Forget the x there, that's a 7. Forget the y there, that's a 3. I end up with this kind of looking number. It's a rectangular array of numbers. This guy here is called a matrix. Right? Matrices are very important, they're very fundamental. We will be using them the entire semester. One thing you'll notice here is that a matrix can represent a transformation. Matrix is the plural of matrix. So we're going to be doing this a lot, writing rectangular arrays of numbers, but we're always going to be thinking of them in a certain light. Sometimes we're going to be thinking of them as transformations. Sometimes we're going to be thinking of them as a list of equations. Anything that's convenient to help us get the problem solved. Right? So this represents a transformation. Right? So in particular, matrices can represent what we call linear transformations. You'll notice in your syllabus there's a whole chapter on linear transformations, so we will go over this again. linear transformations. So let T be a transformation. T is called a linear transformation. If what makes something a linear transformation? There are two properties that make something a linear transformation.
Mapping, if it maps from one thing to another variable. No. Or also.
One thing is, if I plug in a sum of vectors into a linear transformation, what happens is, I can think of this as a transformation applying to each vector separately and being added together.
Yeah, the second one would be like a scalar multiplication.
The second one is scalar multiplication. T of k times the vector A is equal to k times t to the A. Any function that satisfies these two properties is called a linear transformation. Very important kind of function. And we'll be talking about that. And these things we're really going to be getting general here, guys. It's not going to be a kind of walk in the park. There are tons of things that we can think of as linear transformations that you probably haven't thought of as linear transformations. For example, differentiation is a linear transformation, right? Take the derivative of sum of functions, right? If I think of functions as vectors, then if I say t means take the derivative with respect to x, that's a rule that I assign a function to another function, right? Think of the function as the vectors. The derivative of a sum of functions is just the sum of the derivatives. If I take the derivative of a constant times a function, I get a constant times the derivative of the function, right? Integration is also a linear transformation. Integral of a sum is the sum of the integrals, right? A constant times, if I take the integral of a constant times a function, the result is a constant times the integral of the function, right? So these are linear transformations, right? So I can use matrices to represent linear transformations. There are functions that fulfill these two properties.
So why particularly is it called a linear transformation? Is it because there's only one, always going to be just one result?
Because the components will tend to look like lines, right? Remember a line, how it looks? The highest power is going to be a 1, right? So we have the variables to integer coefficients, which are either 0 or 1, right? It'll only have one this. If I do this, it's not going to be a linear transformation anymore. That will not work, because if I square a sum, what's going to happen? I get a middle term, right? So things will mess up. Turns out that the kind of functions, the familiar ones anyway that you know about, that will behave that way, ends up being lines or planes, things that are known to be flat. Of course, we're going to look at other sets as well. So I'm glad you asked. Why am I telling you all this? What is this all about? I'm telling you all this to say the following, because I just wanted to, I want to give you the definition of what we'll be doing this semester, and I kind of needed some background. Linear algebra is, I'm going to tell you what linear algebra is, right? Just so someone can say, what is calculus? Well, it's the study of derivatives and integrals and their applications, right? What is linear algebra? In a phrase, linear algebra is the study of vector spaces and linear transformations between vector spaces. Vector spaces, again, far more general. It's not going to be what you think. right? So usually when people think vector space, they just think, oh, it's vectors like in physics, magnitude and direction. A vector is a far more general concept than that, and we'll be getting into it, right? Basically, a vector space will be something that behaves like the vectors that you're used to, but they don't have to be vectors. For example, a set of matrices forms a vector space, right? If I give you a matrix of a certain size, they would form a vector space, which I talk about next time, right? But this is what linear algebra is. What we're going to be studying is vector spaces and linear transformations on vector spaces, right? We're going to be talking about functions that behave this way, where my elements come from something I call a vector space, which we will define in detail later on. I think that is the third section of the course, right? So first thing we're going to do is we're going to learn how to deal with matrices, how these things work, and do some applications of why they're useful. That's the first section. Those are the first 10 topics. Vector spaces will come next, where I'm going to define in detail what a vector space is. Then I'm going to talk about eigenvalues and eigenvectors, something that's very important as far as applications are concerned. Then I'm going to talk about linear transformations. That's basically the plan for the course, right? And that, by the time you get to the end of that, you'll sort of get an idea of what linear algebra is all about. It's really about vector spaces and these functions between vector spaces that behave a certain way, right? And from studying this, we can apply this to so many things you won't believe how many things this applies to. We are going to be getting into that. So for now, that's the intro. It's sort of where we're going. A teaser to the teaser. Any questions so far? Is everyone confused? Don't worry, it'll get a lot more confusing as soon as it goes.
So you keep telling us at the end of this section and before the section which ones you're going to cover so we'll know for homework?
Oh, I'll be covering them in this order.
Okay.
Right,
So for
and
homework,
once I-
like you're saying, like if you cover 2 sections, we'll know
Yeah,
clearly.
yeah,
Which
I'll know
ones?
from the board.
Okay.
So I'll usually tell you when I finish the section, but you can also follow along in the textbook. Took a little bit longer than expected, but I won't let that deter me, because I have a present for you guys. First quiz of the semester. Put your stuff away. So we didn't do anything, so there's no homework due on Monday, but let's see what you guys know about functions and arguments. Pass those around.